let's do the last couple of problems here. So it says, describe any symmetries. So it looks like if I fold it here, that would work. So 1, 2, 3. Now this one might be hard to see. So let me erase those. I could also fold it here. Interesting, right? So another 4, 5, 6. So if I listed all the ones I could fold, that's a total of 6 lines of reflection, foldings, reflection symmetry. Here, I could fold it there. So that's 1 line of reflection symmetry. This one, so I could put no lines of reflection symmetry. That's like my S. So if I think about this, if I folded this here, then the other hydrogen would land there and there's nothing there. So those are kind of tricky. But it said describe symmetries, plural. So now I have to think about, what about a rotational symmetry? So if I rotated it, and the 1, if I spun it from here, the 1 would land here by the 2, and here again, and here, and here, and here, and then it would land back on itself. So that's 6, a degree of 6 for rotational symmetry. We also call that, when we do 360 divided by the degree of symmetry, that's 60 degrees. So every 60 degrees, it's symmetrical on itself. Okay? Now here, it doesn't look like that would work, right? Only this 1 line of symmetry works, but it doesn't look the same upside down and right side up. And it's not going to line up until I get all the way around. It's just going to look backwards. So I'm going to put no, not rotational. No rotation symmetry. All right, here, this is like our letter S that we talked about. So we notice that it looks the same upside down and right side up. So that's another way to think about this one. This is a frown, and so if upside down, it looks like a smile. So it doesn't look the same upside down and right side up. But if I spin this, it's like, oh yeah, it looks the same upside down and right side up. So that means that it has to be 180 degrees symmetrical. That's the same as, it looks the same here if I spun it. And then if I spun it all the way around 180 degrees, it would look the same here. So that's 2 degrees of symmetry. Rotation. Symmetry. Okay, last 2 questions. So a couple of these we did in class too. When I look at this, it says reflectional symmetry across a vertical. So that looks good, right? I can fold it there. Reflectional symmetry across a horizontal line. So I can fold that here. That'll work out, right? This means looks the same upside down and right side up. So that one works fine. 60 degrees. Okay, so if we draw a right or a equilateral triangle, that's 60. So that's usually 60 degrees symmetrical is usually 3-prong. This one looks like it's going to line up every time you spin it 90. So that's not going to work. These are not going to work. This thing it's going to line up every 4 times. So it's a 4 degree. And so if I take 360 divided by 4, I get 90. I don't get 60 or 120 or multiples of that. So this would be rotationally symmetrical at 90 when I rotate at 190, or if I rotate it 180. because it does look the same upside down and right side up. Great. Last one. Which one can be mapped upon itself with 180 degrees rotation? So this one's actually kind of easy. I just got to figure out which one looks the same upside down and right side up. So I'm trying to turn it upside down. And the only one that looks the same is the letter N. Great job, guys. Can't wait to see you next class. Take care.